Okay, so sine rule part 2. This time we're finding when we've got an unknown angle. So it's still the same sort of rule, and we're still using pairs, but this time we're going to start with using sine A on A upstairs. Okay, so we're still labeling our triangles the same. The angle is A, its opposite length is still little a, and so on. So we're all about the opposites and still with pairs. So let's pop this into an application. So a simple statement like this one. As you can see, we still have a length and its opposite angle, so we've got a known pair. And this time we want to find the angle, so we better have a length here. Let's call that 48 meters. Okay, so this time, because our angle is the unknown, we're going to start with sine of the angle upstairs divided by its length. If you had done the length upstairs, you'd still get the same answer, but you'd include an extra row of working out because you have to flip them. So sine theta over 48. So let's start with this angle here. So it's going to be sine 71, right, over its opposite length, which is 58. We're trying to get theta by itself, so the first thing we're going to do is get rid of this, divide by 48. So to do that, we're going to times, so we times the whole other side by 48. And we're so close because we want theta, not sine theta. So to get rid of theta, we need to use the inverse sine. So sine to the minus 1 of all of this that we had up there. So the most effort that you have to do really is just doing this rewriting. And now it becomes a calculator job. So to our calculator, we can go shift, sine, pop your bracket, put your fraction button, sine 71 over 58 times 48. And we close our bracket, equals, so our angle is 51, we're going to say 51.5. Okay, some of you might wish to go, right, I'm going to do what's in the bracket first, so sine 71 over 58 times 48 equals, and then you can go shift sine of your answer and get the same thing. So however you want to use your calculator, that's fine. Just make sure that you do pop your working down and you double check your work all the time. Okay, so we'll just do one more because there is a little bit of a thing to watch out for here, and this is when we have to think about the situation which is called the ambiguous case. Ambiguous. Oops, what's disappearing there? No. Okay, so once again we have a look and we've got a known pair, and this time it's the same thing that we've had, we've got an unknown angle. So once again we start with That's going to be sine theta over its opposite length is 100 equals the known pair that we have, sine 24 over its opposite length, which is 42. We get rid of the divide by 100 by multiplying. So same, right? We follow the same process as above. So you might want to make sure that you have this as an example somewhere, and we're going to times by the 100. To get rid of the sine, once again, we're going to inverse sine. So sine to the minus 1. Okay, so divided times 100, sine to the minus 1. We pop that in the calculator, we get 75.6. You think, well, that was just the same as the example we did before. However, what you now need to add to your repertoire is that when you are finding the unknown angle using the sine rule, you just have to take a couple of seconds to check for what we call this ambiguous case. Okay, and we do that by simply saying 180 degrees, take the angle that you had. Okay, we work that out. So 180, take 75.6, and that gives us 104.4 degrees. And we add that to the angle that we were given in the example. So 104.4 plus 24. Now when we add those together, it is clearly less than 180 degrees. And so therefore, we actually have two solutions for theta. It can be the 75.6 and, or you could say, or it could be the 104.4 degrees. Okay, so two solutions. And how that comes about is that this length here, that 42, it could have actually come in there and been 42 meters. So we've still got the 24 degrees. We've still got this length is 100. That's still 48. But this angle here could now be the 104.4. Okay. Do you have to check every single time you use the sine rule? You should. It generally only happens for a very small angle, so generally less than 30 degrees, but it does depend on the other lengths and angles that you have. So if we go back up here and we check this one, we do the 180, take 51.5, right? It's not hard calculations, right? 180, take 51.5. This time we get 128.5. Now when we add that to the angle that we have, 128.5 plus the 71, okay, just from approximating, you can see 128%, that is going to be much greater than 180 degrees, okay? So therefore, we don't have two solutions in this case, okay? Not happening. The only answer that we have is the 51.5, and as you can see, our angle here was when we had a large angle. So it's generally when it's 30, 32 and less, that's when you have to always check for the ambiguous case. So hopefully that helped using your sine rule to find the angle.